It is important for students of statistics to understand the formulas for calculating these descriptive statistics we've been talking about, including the mean and the variance and the standard deviation of a data set. So let's have a quick review of how we do that. And we'll talk about a sample here. So the sample mean recall was the symbol is x bar, and we get that by taking the sum of all the values in the data set and divide by the number of values in the data set, our sample size, which is lowercase n. Okay, the sample variance and our symbol there is s squared. We calculated by taking the sum of each value in the data set, the difference of each value in the data set and the mean. We square those, add them all up, and divide by the sample size minus 1. And then finally the sample standard deviation. Which is just s, and here we actually take the square root of the variance, which was the difference between each value and the means. So square those, sum them up, divide by sample size minus 1, and take the square root. Now, as a student of statistics, you should be able to do all of these calculations by hand, like this. And we've looked at doing those using a table to do it. It kind of organizes the data as we go and the calculations as we go. For small data sets, you are expected to know how to do that. But when the data sets get much larger, we really want to be able to use our technology, our TI84. So I want to show you an example of how we would do that. So a survey was taken of adult males at a local gym, and the age of each respondent was recorded. We want to find the mean, the standard deviation, and the variance of this data set. So here's our data. These are the ages of the respondents who took the survey. Okay, and so let me pull this up now that we know what our task is. We've got our data and our calculator, the TI84. Okay, so we want to turn our calculator on, and we're going to first enter our data. So we use this button stat, the stat button, and we want to edit. That's when we enter the data. It's highlighted at the top here, edit, and under edit we have all these choices. We want the first choice, edit. So it's already initiated. So we just enter to say that is what we want. And now we have columns of lists. And I'm going to put my data in list 1. And we do that. I'm going to look over here and enter each value individually. So the first one is 22. Notice it says list 1, value number 1. And I put in 22, hit enter. And now it's ready for list 1 and my second value in the data set, which is also 22. Enter. 20, 19, 33, 31, 26, 18, 23, 28. Okay, I'm halfway through. I've entered 10. Look, it's how it's waiting for the 11th value. My 11th value is 19, 21, 27, 29, 38, 29, 22, 22, 26, and 32. Enter. And by inspection, I can look at my data set. I've got 5 in each row and 4 rows. I know I had 20. So that's kind of helpful. If I already know that, it's good to make this check where I look and see that I have entered 20 values, and I know I have because it's anticipating the 21st value, and there isn't one. So I'm finished with entering my data. So I go back to my Stat button, and now this time I want to calculate. So I'm going to use the right tab key over to calculate, and these are all my options under calculate, and I want the first one. I have one variable statistics. It's already initiated, so I'll hit enter. Now here it's looking for what list my data is in. Now my data is in list 1. Let me show you. If I had put it in list 2, then I would need to tell the calculator that that's where my data is. The list numbers are above the numbers on the keypad. So above the number 1 in blue is L1, above the number 2 in blue is L2. So by hitting the second key, or the blue key, I'm telling it to use these functions. So if I had put it in list 2, I could say second and 2, and notice how it changed it to 2. But I did not put it in 2, I put it in 1, so let me fix that. Go back to list 1. Once you do a lot of work in statistics, whoops, let's go back. I'm going to delete that one and go back, delete that one, and let's put in list 1. You'll be using more than one list a lot of times, so you'll need to keep in mind and note where you have put your data when you get to this point. It's asking me if I have a list of frequencies that go along with those values, and I don't, so I'm not going to put anything there. I just want to calculate, so I'll just hit enter. Get down here, initiate calculate, and enter. And here are my one variable statistics for my data set. Now it asks me to find the mean x bar. There it is. My very first value is my mean. So my my mean is 25.35. Okay. I guess I'll just write that and have to pull it back up. Okay. X bar 25.35. Now remember our rounding rule. It said one more decimal place than the data. The data didn't have any, so I'm going to call this 25.4 years, because this data is in years. Okay, let's go back to our results. Now let me just point out here at the bottom we see n equals 20. That was probably should have pointed that out at first to say when you first get here, if you know you should have put in 20 values, that's a good check. If that number had been 19, I'd know I missed something. 21, I might have entered something twice. So it's not a bad idea to check on that. Okay, it also asks for the standard deviation. We see here an S sub x and a sigma sub x. Recall that S represents the sample standard deviation, sigma represents the population standard deviation. And those calculations were slightly different. Remember, for sigma we're dividing by for S, for a sample, we divide by n minus 1. For sigma, we just divide by the population size. So that's why these values are going to be slightly different depending on whether you have a population or a sample. We had a sample, so my standard deviation here is 5.4509777701. That's what they're reporting. But now again, rounding rule says one more decimal place than the data. The data had no decimal places, so I'm going to round this, and this would round, that 5 there would round that 4 up to a 5, so my standard deviation is 5.5. So be careful when you're selecting this. If it's a sample, it's S. If it's a population, it's sigma. 5.5. So S is 5.5, and this is in years also. And now we need the variance, S squared. This arrow tells us there's more below, but as I tab down I see there is no S squared. That's as far as it goes. No S squared. We'll talk about those values later, but for now we're just looking for the variance. So the reason we don't have that here is, for the most part, recall we said when we talk about variation we're going to use standard deviation. So there it is. Your TI84 has given you that. If you need to answer the question of variance, what can we do? We can square the standard deviation. Now here's the caution. if I just square 5.5, I'm going to be off by a bit because that was an approximate value. I rounded that. So to find my s squared, I'm going to take the 5.45 and carry out a few more decimal places and square it, then report that answer to 1 decimal place using my rounding rule. Okay, so my s squared is going to be 5.45. I want a few more decimal places. Let's say 0.9778, round there, and we'll square that. And what we get here is about 29.713 rounded, and of course now let's just approximate that to 29.7. And remember the units here, years squared. I squared years, I get years squared. Okay, 29.7. So this is how we can use the TI84 for these large data sets to calculate our descriptive statistics. But again, you should be able to do this using the formulas for smaller data sets.